ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಪೋಲಾರ್ ಕರ್ವ್‌ನ ಟ್ರೇಸ್ ಮಾಡೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವರ್ಕಿಂಗ್ ರೂಲ್‌ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಮೊದಲು, ಆಮೇಲೆ ಕಾರ್ಡಿಯಾಡನ್ನು ಹೇಗೆ ಟ್ರೇಸ್ ಮಾಡೋದು ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಫಸ್ಟ್ ಪೋಲಾರ್ ಕರ್ವ್ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಅ ಕರ್ವ್ ದ್ಯಾಟ್ ಈಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಥ್ರೂ ಪೋಲಾರ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್. ಸೊ ಜನರಲಿ ಇಟ್ ಲುಕ್ಸ್ ಲೈಕ್ r equal to f of theta or f of r comma theta equal to 0. Equation I have written. So polar equation ಅಥವಾ polar curve ಅಂತಂದ್ರೆ curve that is represented through polar coordinates. So what are the important points you have to analyze to sketch the graph of the curve looking into its equation? So first important point is symmetric. As in the case of Cartesian curve, here you have to identify symmetricity. So here there are three major points. First one is whether curve is symmetric about initial line. ಸೊ ಕಾರ್ಟಿಷಿಯನ್ ಫಾರ್ಮಲ್ಲಿ ಏನು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅದನ್ನ ಇಲ್ಲಿ ಇನಿಷಿಯಲ್ ಲೈನ್ ಅಂತ ತೊಗೊಂಡಿರ್ತೀವಿ. ಇನಿಷಿಯಲ್ ಲೈನ್ ಸಮ್ಟೈಮ್ಸ್ ಪೋಲಾರ್ ಆಕ್ಸಿಸ್ ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. ನೆಕ್ಸ್ಟ್ ದ ಲೈನ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟು ಟೀಟಾ ಈಕ್ವಲ್ ಟು π/2. ಕಾರ್ಟಿಷಿಯನ್ ಫಾರ್ಮಲ್ಲಿ ಇದು ಪಾಸಿಟಿವ್ ವೈ ಆಕ್ಸಿಸ್ ಆಗಿರುತ್ತೆ. ಆ್ಯಂಡ್ ಅಬೌಟ್ ದಿ ಪೋಲ್ ಅಲ್ಲಿ ಆರಿಜಿನ್ ಅಂತ ತೊಗೊಂಡಿದ್ವಿ, ಇಲ್ಲಿ ಪೋಲ್ ಅಂತ ತೊಗೋತೀವಿ. ಕಾರ್ಟಿಷಿಯನ್ ಫಾರ್ಮಲ್ಲಿ ಆರಿಜಿನ್ ಇತ್ತು. So what are the conditions for this? See, the curve will be symmetric about the initial line if f of r comma minus theta is same as f of r comma theta. If you interchange minus theta, I mean theta by minus theta, even after interchange you get the same equation, then the curve is symmetric about the initial line. If changing theta to minus theta keeps the equation unaltered, then the curve is symmetric about initial line. Next, corresponding, in symmetricity about the line theta equal to π/2. That is happened when f of r comma pi minus theta is f of r comma theta. Replacing theta by pi minus theta gives the same equation. Then the conclusion is the curve is symmetric about the line theta equal to π/2. And the curve is symmetric about the pole if f of minus r comma theta equal to f of r comma theta. Curve is symmetric about the pole if f of minus r comma theta equal to f of r comma theta. So these are the three conditions you have to check for symmetricity. So next important point, as in the case of Cartesian form, special points. Special points. Here first we check whether the curve is passes through pole. So for that, passing through pole, for that you have to put r equal to 0. See, polar coordinate system, it involves direction and distance. If this is some point, then we will be having radius vector r and some angle theta. So if you make this r 0, we will be at pole. So I have to put r equal to 0. So when you put r equal to 0, whether you consider this form or this form, then as soon as you put r equal to 0, then we get some particular value to theta. We get some particular value, say theta equal to theta 1. Then the line corresponding to theta equal to theta 1 will be tangent to the curve at the pole. ಸೊ ಕಾರ್ಟೇಷಿಯನ್ ಫಾರ್ಮಲ್ಲಿ ನಾವು ಆರಿಜಿನ್ನಲ್ಲಿ ಟ್ಯಾಂಜೆಂಟ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಲಿಲ್ಲ, ಅದನ್ನು ಅಷ್ಟೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲ ಅಂತ ತಗೊಳ್ಳಿಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ we have to discuss about the tangent to the curve at the pole. How to get the tangent to the curve? By letting r to 0. So r equal to 0 ತಗೋಬೇಕು, ಥೀಟಾಗೆ some value ಸಿಗುತ್ತೆ. So corresponding to that angle, you have to draw a straight line. That line will be tangent to the curve at the pole. Next, specific points. specific points. Here you have to write a table of values of r corresponding to values of theta. So construct a table. This actually gives a brief idea about the graph of the given curve. You have to write various values of theta. So theta equal to some 0, pi by 2, just like looking into the given equation, you have to write various values of theta, and corresponding to that you have to collect values of r, that is specific points. So fourth one, this is not so important, but even we need this for our knowledge. Reason of existence. Reason of existence. Here I had to collect all the values of theta such that r square is greater than or equal to 0. You have to just delete the values of theta for which r square is negative. So negative ಇರಲ್ವಲ್ಲ ಅಂಥದ್ದು ಮಾತ್ರ ತಗೋಬೇಕು. ನೆಗೆಟಿವ್ ಇದ್ದರೆ ಡಿಲೀಟ್ ಮಾಡೋದು, ನೆಗೆಟಿವ್ ಇಲ್ಲ ಅಂತಂದರೆ ಆ ವ್ಯಾಲ್ಯೂಸ್ನೆಲ್ಲ ತಗೋಬೇಕು. ಯೂಶ್ವಲಿ ಇದು ಅಂತ ಒಂದು ಕ್ರೂಷಿಯಲ್ ರೋಲ್ ಬರಲ್ಲ. And last point, we have to find the tangent to the curve. So ಒಂದು tangent already discuss ಮಾಡಿದ್ವಿ, tangent to the curve at the pole. Sometimes you may get tangent to the curve at some other point except pole. How to find it? For that, for the tangent to the curve, except at pole, so determine tan phi, that is r equal r into dr by dt. So this actually gives the direction of the tangent to the curve, the direction of the tangent to the curve. So these are the important points you have to note down. So among these points, first 3 points are very much important. You have to find where the curve is symmetric, symmetricity, then special points and specific points. Actually these 3 points gives you almost all the required idea for sketching the graph of the given equation. Next, let us consider the example. Trace the cardioid, trace the curve r equal to a times of 1 plus cos theta. So this is called cardioid. So here a will be a positive constant and theta lies between 0 and 2 pi. Okay, now let us analyze this solution. Given r equal to a times of 1 plus cos theta and a greater than 0 and theta lies between 0 and 2. So this is the given one. So let f of r comma theta equal to r minus a times of 1 plus cos theta. But if you look into this, the notation is not so familiar. So you can neglect it, or you can write f of theta is a times of 1 plus cos theta. Just I have compared this with r equal to f of theta. So ಇದು ಅಷ್ಟು ಫೆಮಿಲಿಯರ್ ಅಲ್ಲ, ಸೊ ತಲೆ ಕೆಡ್ಸ್ಕೊಳ್ಳದೆ ಬಿಡೋದು ಅಂತ ತೆಗೆದು ಹಾಕೋಣ. Now replace theta by minus theta here. Replace theta by minus theta here. So we get f of minus theta. That is a times of 1 plus cos of minus theta. But cos of minus theta is cos theta. You get a times of 1 plus cos theta. So that is same as f of theta. So replacing theta by minus theta, the equation is unaltered. Therefore, curve symmetric about initial line. The curve is symmetric about initial line. Okay. So next, you have to check whether the curve is symmetric about the line theta equal to pi by 2. Whether the curve is symmetric about the line theta equal to pi by 2. So you can obviously check that f of pi minus theta will not be f of theta. So curve is not symmetric about initial line. And also you can check that the curve is not symmetric about the pole. So regarding symmetricity, we get only this point. And then next point you have to note down special points. Next one is special points. So for special points, we have first we have to check whether the curve passes through pole. Special points passing through pole. For this, you have to put r equal to 0. Put r equal to 0. If you put r equal to 0, you get a times of 1 plus cos theta equal to 0. But a cannot be 0, so that implies 1 plus cos theta must be 0. So cos theta must be equal to minus 1. So that is happening only when theta is pi. So this is the particular value of theta. So curve is, yes, the curve is passing through the pole when theta is pi, and the line corresponding to theta equal to pi, that itself will be the tangent to the curve at the pole. Okay, so from these 2 points, these are the informations we have gathered. This is x-axis and this is y-axis, and this we call initial line theta equal to 0. This we call the line corresponding to theta equal to pi by 2. This we call the line corresponding to theta equal to pi. This is the line corresponding to theta equal to 3 pi by 2, right? And this is the pole. From symmetricity, we have only one information. Actually, there are three information. First one is curve is symmetric about the initial line. So you have to just worry about the upper of plane. This quadrant and this quadrant, you have to worry. And curve is not symmetric about the line theta equal to pi by 2. Curve is not symmetric about this line, and the curve is not symmetric about the pole. And then under special points, what we got is the curve is passing through the origin when theta is pi. So when theta is pi, curve passes through the origin, and this line will be the tangent to the curve at the pole. Okay, that is the second point. And third point, I had to construct the table specific points. I'll write the table like this: theta and then r. So values of theta will take 0, pi by 2, 2 pi by 3, pi, 3 pi by 2, 2 pi. If you want, you can add few more points: pi by 4, 3 pi by 4. ಅದು ಕೂಡ ಪಾಯಿಂಟ್ಸ್ ಆ್ಯಡ್ ಮಾಡ್ಬೋದು, ಇಷ್ಟಕ್ಕೆ ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡಬೇಕು ಅಂತೇನಿಲ್ಲ. ಸೊ ವೆನ್ theta is 0, when theta is 0, r will be 2a. See, equation is r equal to a times of 1 plus cos theta. When theta is 0, cos 0 1, 1 plus 1 2, so you get r equal to 2a. When theta is pi by 2, cos pi by 2 is 0, you get r equal to a. When theta is 2 pi by 3, r will be a by 2. When theta is pi, r will be 0. When theta is 3 pi by 2, you can check r is a. When theta is 2 pi, r will be 2a. So just mark these points. See, when theta is 0, say 2a will be somewhere here. 2a. When theta is pi by 2, this line, R will be A. So somewhere here, this is the point. When theta is 2 pi by 3, somewhere here you get R will be A by 2. So A andre A by 2. When theta is pi, R will be 0. When theta is 3 pi by 2, is this line. When theta is 3 pi by 2, R will be A again. Again somewhere you get here. Or if you want, you can neglect this reason, just concentrate on upper half plane. Same thing can be reflected in the lower half plane. No need to worry about this again. Yes. Now if you join these points, so same thing should be reflected here. So this is the actual graph of the function. This is the actual graph of the function. There is one more point I think I should have mentioned already. If you take modulus of R, that is again clear from this one. Modulus of R, that is modulus of A into 1 plus cos theta. Just to guarantee this, I am doing this. So that is A greater than 0, no issue. A modulus of A is A itself. Modulus of 1 plus cos theta, that will be less than or equal to modulus of 1 plus modulus of cos theta, it will be 2. So modulus of R is less than or equal to 2A. So entire curve lies in the region R less than or equal to 2A. So that guarantees this, and this is correct. So this is about the tracing of the chordioid. See the actual chordioid, we have the figure here. Yes, this will be actual graph of the chordioid. ನಾನು ಹಾಗೆ ಸುಮ್ಮನೆ ಸ್ಕೆಚ್ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ. Actual chordioid, this is the exact graph. So this completes the solution of tracing of chordioid. So with this we have discussed how to sketch the what are the steps. Yes, what are the steps to sketch the graph of a polar curve looking into its equation, and also we have considered one example for that. So I hope we understand the concept from this, and let us wind up this video. Thank you.